Now we have a couple of examples in examples 5 and 6 here, module 2.2, where we are given some information about the function and asked to actually form the equation of the function. That's kind of flipping the script a little bit, and it's important that we learn how to do that. In all the examples so far, we've been given a quadratic function and asked to find some information about that function. Now we're taking it the other direction. We're given some information about the quadratic function and asked to go back and find the form of the function. That's an important skill to have to make sure we understand our way around these polynomial functions and these quadratic functions. And it's also very important in applications, and certainly business applications, where we have some data points in our business and we want to form a model for those observed data points. That's exactly what we do with taking information about a function and forming the equation of the function from there. But let's get back to this example. We're asked to use the vertex that we're given h, k and the point on the graph x, y to find the general form of the equation of the quadratic function. So here we are going to use what we know, and not just the numbers that we're given, but by use what we know, I mean we know the form of a quadratic function. This is a quadratic function which we already know has the form f of x equals a times x minus h squared plus k. And for that matter, we are given the vertex. We know h and k. Perfect. We can start there. Plug in 2 for h and 0 for k, 2 for h and 0 for k, and we've got f of x equals a times x minus 2 squared plus 0. I'll simplify that a little bit because anything plus 0 is itself, so we don't really need to write the plus 0. We can just write f of x equals a times x minus 2 squared. Now the problem is we don't know a, and we're not immediately given a as part of the problem. But I do know an x value and a y value, and the idea now is that we will plug in that x value of 4 and that output value. When we plug 4 in for x, we get 4 as the output. So I'm going to plug in 4 for x and set that equal to 4 for the output, and let's see what that looks like and how that helps us over here on the left. If I plug in 4 for x, and then set the output to 4 as well, then what that gives me is an equation that only has one unknown, a, and I can solve for a. So let's actually just do the math, do the arithmetic of that. In the parentheses, 4 minus 2 is 2, 2 squared is 4, so I've got 4 equals 4 times a. Easily dividing both sides by 4, we find a equals 1. So if I'm given another point on the graph, I can plug in the input and output values to solve for a. Now that I'm not going to box the answer a equals 1 because that's not what they were asking me to find. They were asking me to find the equation of the quadratic function. So I'm going to go back to the equation of the quadratic function and say, okay, now I know f of x equals a times x minus h squared plus k. I know a, I know h, I know k. I can plug in those pieces of information and get my actual equation of the function. Once again, I'll say plus 0 doesn't really make any difference. We don't have to write plus 0. Similarly, times 1 doesn't make any difference to the function, so I don't have to write the 1 in front of the parentheses, and in fact I can simply write f of x equals x minus 2 squared as my answer. I could also FOIL that out and get the ax squared plus bx plus c form, but either way we have the equation, the formula for this quadratic function. Let's do that again here. where we are writing the equation for this graphed function. Here's a parabola. We know that's a quadratic function, and the simple fact here is that question 6, example 6 here, is exactly the same in form as example 5. We're given the information visually instead of as numbers, written out numbers, but the information is the same. In example 5, we had we were given the vertex of the parabola. Well, I can look at this graph and I can identify the vertex. And we were given another point on the graph. I can look at this graph and I can identify another point on the graph. So I have the same, in fact, I actually have more information here than I had before, but I have the same type of information and I can do the same type of work. That's exactly what I want to do. To find the equation of this function, I start with my equation, f of x equals a times x minus h squared plus k. And then I recognize, looking at the graph, that my vertex occurs at the point -1, 2. So h is -1 and k is 2. And I'll plug those in to my function here, a times x minus h squared plus k. And I'll do a little bit of simplifying because x minus -1 is the same thing as x plus 1. So I've got a times x plus 1 squared plus 2. Now I still don't know what a is, but I'll do the same thing that we did in example 5, where I pick another point on the graph. And you can pick any point that's a perfect point that you can recognize on the graph. Really simple one to see on this graph is the y-intercept. The y-intercept of 0, 3. So let's use that point with x is 0 and y is 3. The input is 0 and the output is 3 to match up an input of 0 and then an output of 3 to solve for a. Do the math. 0 plus 1 is 1. 1 squared is 1. So we just have 3 equals a plus 2. Subtract 2 on both sides. And we get a equals 1. Knowing now that a equals 1, we go back to our function. F of x equals a times x minus h squared plus k. And we have our equation of the function. One more time, I'll simplify to say that I don't have to write 1 times in front of the parentheses. And the simplest form of my standard form here is f of x equals x plus 1 squared plus 2.